All right, this lecture is on earthquake hazards. So, the earthquake hazard, we have the ground motion. So, there's a lot of shaking, things get broken with that. Um, Offset along the fault can break power lines and pipelines and roads and bridges and things that cross the fault. And you have aftershocks as well, which are not as big, almost always not as big as the main earthquake event, but still those have seismic waves as well and more shaking with them. Um, you also have ground failure, which are landslides and liquefaction. We'll talk more about liquefaction in a little bit. And then you have some coastal hazards like tsunamis. So, how do you handle earthquake hazards if you're living in an earthquake prone area? It really comes down to engineering. There's not much you can really just do as a person, but we are now like an individual person. But as a society, we are making more earthquake resistant buildings and bridges. We're using different materials. On bridges, we're putting in like little roller devices so the bridge can kind of shake back and forth and just roll on these rollers rather than breaking. Um, Using a lot of science and a lot of engineering just to make sure that our structures can withstand these forces. There is that little caveat at the bottom there that unfortunately, though, all of these um, engineering there we go. Engineering codes are only applied to new construction. So if you're in an older building, unfortunately, the new science and engineering codes just will not help you much. And here are some examples of here we have some poor engineering code. So you can see these other buildings stood, this one didn't. It was a little older. Um, and then here you have this house or a church, it looks like. Or portions of it have fallen, but yet this other building seems to have fared much better. We have just some pictures here earthquake damage of freeways. These are all bridges that have given way. And here are some pictures of liquefaction. So, liquefaction is really, it's just kind of when almost like the ground becomes quicksand underneath you. So, it happens in uh, soil without a lot of cohesion, so usually more like a sandy material that is wet. And then when you start shaking it, the grain on grain contact is lost because it's just shaking so much. The grains kind of separate and it effectively becomes like quicksand material and it just gives way. And so these are some pictures here of liquefaction. And then the same thing can happen, but if it happens on a slope, a hill of some kind, then it's a landslide. We call it liquefaction when it happens just on flat ground and it can just give away even on a flat surface. Tsunamis and coastal hazards. These happen when there is an earthquake at the coast. And so either it can be from if there's an earthquake and a chunk of land falls into the ocean and creates a large wave, or it can be when the fault is actually in the ocean and the ocean floor comes up and then pushes a wave up over the land. Either way, they're very deadly, very huge waves. So if you're by the coast after an earthquake, you need to watch those tsunami warnings. And if you see the water starting to recede, that actually means a large wave is coming. And you do not walk towards the ocean at that point. You run the other direction. Um, let's see. I'm trying to read what is all written here. See if I covered everything. Yes, I think I did. And then this is just tsunami reporting. So we have little floating devices that read the waves and they speak to satellites. So you can, well, people like NOAA, the National Oceanic Atmospheric Administration, um, they can monitor the waves' size and progression and speed direction too. And then they can kind of predict when one of these tsunamis will be hitting a certain coastal area. Other earthquake hazards, fires, if you get like a gas line breaks or something, water lines can be broken, utility lines, so a lot of without power, without gas. And that is it for earthquake hazards.